and welcome to today's live GCSE math session, which is about ratio today. My name is Melissa and I'm your host for this live online lesson. I'm the in-house math teacher at ICS Learn, so I should be available throughout your support period. You can of course contact your tutor at any point, but I'm also here if you've got any questions about the lessons or just general questions about the course, and I'm available during normal office hours. That phone number will take you directly to my line at my desk. If I'm not there, you can leave me a message on my answer phone or email me mathsteacher@icslearn.co.uk. So today we're going to be covering ratio. I know that spiral staircase doesn't really say much about ratio, but I like spirals and it was a nice picture and I thought it was kind of mathematical, so that's the one I chose for today. So we're going to cover ratio notation, what it means. How to simplify ratios, which works a lot like simplifying fractions. So hopefully, I know some of you might not have watched the lessons on fractions yet, but the ideas are very similar and it should all link with fractions. And we'll also look at how to divide amounts into given ratios, which also kind of works like fractions. And ratio and proportion and fractions are all very closely linked and are a very important part of the new GCSE 9-1 syllabus. Now, sometimes they like to ask quite complex questions on ratio in the exams. I'm just going to cover the basics today of how ratio works, and then later on in the year, when I start going through past paper questions in the webinar sessions, then we'll take a look at some ratio problems that might come up in different contexts and how to go about solving those. I've tried to keep to about 1 hour. I don't think today's lesson will go over. I've not got too many slides today, and this is being recorded. So if you're watching live and you miss a bit, you have to go away and come back. Don't worry, because you can watch it back later on. Do make notes. I know I always say this, but I think it's really important to have everything written down. It will help you to remember what I'm saying, and you can use your notes for revision later on. And you can apply your own special style if you find colours and highlighters and everything like that helpful. You don't have to copy everything from the slides, but do copy down the key points and try to copy down some of the worked examples so that you can refer back to them as you're working through your own practice exercises. And I must stress that practicing maths is more important than anything else. So you can watch every single one of my webinar lessons and write everything down and learn everything that I say off by heart. But if you don't spend a considerable amount of time, I would say at least 2 hours for every lesson, practicing questions, then you won't really learn the materials in the way that you need to for maths. So to really understand it, you need to work through a number of problems to know that you've understood the ideas introduced. I will refer to the calculator from time to time, and the one that I recommend, I think I've mentioned this previously, I think I've put the same number in there. That should be either the FX83 GT Plus or the FX85 GT Plus. One is solar and one is just a battery operated one. So either of those, let me just change that. Try not to make mistakes on my slides, but sometimes I prepare them in a bit of a hurry and I don't quite check them through. So you can get the FX85 GT Plus. Just get whichever one's cheaper, and it will change depending on what special offers there are about. If you're watching live in September now, these are on special offer in quite a lot of places. I think it's only $4.99 on Amazon at the moment, but it changes all the time. You could pay up to £12, so it depends. But you will need a calculator like this, and you'll need it for 2 of the exam papers. So make sure you get one as soon as possible if you don't already. Now, if you're watching the WebEx recording of this, and I suggest that you do watch the WebEx version if you can, because it's much higher resolution. You won't see my lips moving out of sync with what I'm saying as happens in the YouTube versions. But one thing I will say is that the chat box doesn't automatically open, so you must have a chat box open, because then you can see what other students are saying during the course of the session, and you can also click on any hyperlinks that I give you. So for example, I'm going to give you links to the textbook chapters and the answer books and any other resources that you might find helpful. So open up the chat box, click on view at the top of the screen, then select chat, and the chat box will open. You'll also notice that when something goes in the chat box, there'll be a little red icon on the top. And if you've got a different resolution monitor, you might need to move some of the panels out the way if they're obscuring the slide. So that's all interactive for you. And if you're watching the YouTube video version of this, by all means use the YouTube videos. They're good if you can't get WebEx to run on your device. But all of the links will be, you can't click in the chat box if you're watching the YouTube version. So I will paste all the links in the description box under the YouTube video. You click on show more underneath, they'll pop underneath, and you can use the links that are there. It's just not such a good resolution. Let me just, so if you are watching this on YouTube, I'm just going to give you this link. Go to the description box under the video, Ryan, you can't open the chat box. If you've just typed this in, then you must be using the chat box now. So if you're watching live, the chat box will already be open for you. So notice those of you that are watching live on the, I know I'm pointing this way, but I'm seeing a mirror image of what you're seeing. If you go to the right-hand side of the screen, you'll see right at the top it says chat, and there's a speech bubble, and you can use that to turn the chat box on and off. So click it, it will turn off. Click it, it will turn back on again. So that link that I just gave you there, if you click on that and you're watching live, or if you're watching the WebEx recording, that will open up the link to the GCSE recordings, and that's where you'll find the high-resolution WebEx version of this, and it's more interactive, and the sound quality is better, and the slides are higher resolution. So do watch that version if you can. Only watch the YouTube ones if you're on a phone or a device that doesn't run WebEx. Is that okay? All right, let's get on with the lesson. Now, this lesson corresponds to section 5 in your Unit 1 on your course page. I'll give you direct links to those two bits there if you want to go and complete those activities. There's no videos for these. There's only videos for the earlier ones, but if you want to complete some questions, we've got understanding ratio and dividing in a given ratio and ratio problem. So that's on the page, and when you've done it, it's not on here because I've probably cropped it off. When you've done that section, you'll notice that there's a little box like this, and if you click in the little box, it will put a little tick. So once you've completed it, you can click that tick, and then as you work through, you know what you've done. For those of you using the textbooks, I know not everyone's using the textbooks because I think some people find them a little difficult, but most people should be able to access the foundation tier book. Even if you're doing higher tier, I think it's easier just to work through the foundation tier exercises for now. So in the textbook, it's the foundation tier book chapter 19. I'm going to just give you a link to a PDF version of that chapter, just so it's easier. So you can use that, and then a link to the answers. All of chapter 19 covers ratio, so do as much of that chapter as you can, and there's lots of worked examples and sort of description of the theory, so read through that chapter as well as looking at the exercises from worked examples. And then if you want to work through the harder questions, try the questions in the higher tier book. If the foundation tier is not challenging enough for you and you want to try something a bit more difficult, now that doesn't mean to say that you need to do the higher tier book if you're doing the higher tier exam. It just might be slightly more difficult and more challenging questions in there. But ratio is probably around a grade 4 to 5 level, so those questions would appear on both the higher and the foundation tier exam papers. There's quite a lot of overlap. Okay, so that's what we'll go through today. So first of all, using ratio notation. Now, hopefully ratio is something that you've maybe seen before, but ratio is used when you're comparing the amount of one thing to the amount of another thing. Usually 2 different things, but it can be 3 or more. So we've got a very easy warming up question. So in this image, we've got purple stars to green stars. What is the ratio of purple stars to green stars? So how many purple stars are there and how many green stars are there is kind of what I'm asking. So Rob is saying 1 to 2, Stuart thinks 1 to 3, 2 to 4. Yep, so we're getting lots of different answers, that's good. I mean, there's actually 2 different ways of writing this ratio down, so I'm glad that there's 2 different ways here. The simplest way, first of all, is to say, so the first thing to notice is we're asking for purple stars to green stars, so we need to get it the right way round first of all. So what we're asking for is the number of purple stars, which is 2. 2, and the way we represent 2 as a ratio is we do 2 little dots like this, 1 dot above another one. So the number of purple stars is 2. The number of green stars is 4. So we just write it like that, 2 to 4. There we go. We just read the 2 little dots like that is read as 2 to 4. And Gemma, thank you. You said 2 to 4. And I know what you mean by /, but that is equivalent to 1 to 2. Because what we can say, so supposing I'm just going to clarify this a little bit. So I'm just going to draw a little circle around there. A little circle around there. Just kind of highlight why these 2 ratios are equivalent. So we could say that for every purple star, there's a purple star, there are 2 green stars, like that. So for every purple star, there are 2 green stars. So the ratio 1 to 2 is equivalent to the ratio 2 to 4. It's a lot like cancelling fractions down. As long as you divide both numbers by the same thing, you will get an equivalent ratio. Or you can multiply both numbers by the same thing to get an equivalent ratio. So in that way, it works like a fraction, because it's a proportion. We're comparing how many of these compared to how many of these. Now, I think someone said 1 to 3. I can kind of see where you're going with that. So you're maybe thinking of here's 3 stars, and there's one of them. So maybe that's what you're thinking of. Now, I can see where that idea's come from, because if I said to you what fraction of the stars are purple, then it would be 1/3. But the numbers are not quite the same. So what you need to do is you need to add the 2 parts. We've got 1 part to 2 parts. Add those 2 together to get 3. So 1/3 is purple and 2/3 are green. So it's important not to confuse fractions and ratios, because they do work slightly differently. But we'll do more examples on that in a minute. Stuart, your chat box was hiding the other 2. I didn't see what you typed. They all looked right. It's good. Make sure that you do write the 2 dots. So don't do a forward slash instead of the 2 dots. It must be a dot to be a ratio. And we can also say, if someone said, what is the ratio of green stars to purple stars, we swap the numbers around. So there are 4 green stars and 2 purple stars, so we can do it the other way around, and that's the same as 2 to 1. So it's important to get the order of the numbers right as well. So we can simplify ratios, as I said, by dividing the numbers into by a common factor. So remember, a common factor just means a number that divides exactly into both of the numbers that we're faced with. So just exactly like fractions. So, for example, here we've got 20 women and 15 men working in an office. What's the ratio of women to men in the office? And then write the ratio in the simplest form. So in the first part A, we're just going to write the numbers that we're given, and then in part B, we're going to simplify that ratio. So let's have a look. Some people are doing part B, some people are doing part A. Now, it's not because everyone who's typing in the chat box is really on form and answering all of these correctly that everyone will be following this. So if you're not saying anything, don't worry. You might not be the only one who maybe doesn't know how to do this. So very simply, 20 to 15 is the ratio of women to men. Make sure you put the 20 first. And then to write that ratio in its simplest form, we're just looking for a number that divides into both 20 and 15. Now you should spot straight away that both those numbers are in the 5 times table. 20 divided by 5 is 4, and 15 divided by 5 is 3. So completely correct, everyone that's written that. So we divide both numbers by 5. If we divide both numbers by 5, you can just go like that. So put a little arrow on both sides. So divide both numbers by 5, we get 4 to 3. Okay, brilliant, perfect. And everyone who's been brave enough to type into the chat box has got that right. Well done. Now, sometimes the ratio might contain units, so like meters and centimeters, hours and seconds. The important thing to remember is, supposing we were comparing a number of centimeters to a number of meters, we have to decide what units we're going to use. So either both of them have to be in centimeters, or both of them have to be in meters, or pence and pounds. Either both would have to be in pence, or both numbers would have to be in pounds. And then we take away the unit once the units are the same. Usually, if you can convert to the smaller unit, that would be best, because then you've got you're less likely to have decimals in there, and then we can simplify our ratio in the next stage. So let's have a look at an example. So this one involves minutes and hours. So for every 40 minutes, there are 2 hours in this ratio. So the first step will be to convert to the smaller unit, so to convert these into minutes. So 40 minutes, we'll leave that as it is. How many minutes are there in 2 hours? 2 hours, careful, Abdallah, every hour is 60 minutes, 60 and 60 is 120. So 2 hours is 120 minutes. So the first step will be to write this as 40 minutes to 120 minutes. Once both of them are in the same unit, we can just divide by minutes, so we can just cancel that through. So it's just 40 to 20. Once it's 40 to 20, then we can simplify it just by dividing both numbers by the same thing. Now, obviously, they're both divisible by 10 because they both end in a 0, so I could put 4 to 12. But I can also divide both 4 and 12 by 4, and actually 4 goes exactly into 120 3 times. So if I divide both of those numbers by 40, you can do it by 10 and then by 4 if that's easier, then what do I get? Bernice, thank you, by 40. 1 to 3. Violet, Bernice, Ali and Gemma Fantastic work. So we divide both of them by 40, and our ratio is 1 to 3. So the ratio 40 minutes to 2 hours is equivalent to the ratio 1 to 3. Because 2 hours is 3 times 40 minutes. And we often quite like ratios that are in the form 1 to a number, because it's just an easier way of comparing the relative sizes of the two amounts. So often you'll be asked to write ratios in the form 1 to n, where n is just a number. And usually the simplest form is where both numbers are the lowest whole numbers possible, but other times, and I'll go into some examples, we want it 1 to a number. Sometimes they cancel down like this, and sometimes they don't. So this is what I'm talking about. So writing ratios in the form 1 to n. Now, I know we haven't done algebra yet, but in math, n just means a number. So it's just a shorthand for saying a number, any number depending on the ratio. So another way of simplifying a fraction, other than just dividing both things to get it down to its lowest form so that both are whole numbers, is to write it like this, 1 to n. So let's have a look at an example. So here we're asked to write the ratio 8 to 12 in the form 1 to n. Now I can just cancel this down in the same way. Both 8 and 12 are divisible by 4. So if I divided both of these by 4, 8 divided by 4 is 2, and 12 divided by 4 is 3. So I could simplify that ratio by writing it as 2 to 3. But here I want the first number to be a 1. So if the first number is a 1, what's the second number going to be? So what you kind of need to ask yourself is what do I do to 8 to make it 1? And then do the same thing to 12. So to go from 8 to 1, I need to divide by 8. So to keep the ratio the same, I also need to divide the 12 by 8. Let's have a look how that works out. So we're going to divide both of these numbers by 8. 12 divided by 8, there's a few different ways you could do it. You could do it on your calculator, or you could do it as a fraction. You could say, okay, 12 over 8. That's equal to, well, I'm just going to change this to a mixed number, but first I'm going to cancel. So 12 and 8 are both divisible by 4. 12 divided by 4 is 3. 8 divided by 4 is 2. And then 3 over 2, 3 halves is equal to 1 and a half. You can write it as 1 and a half, or if you prefer decimals, you can write it as 1.5. So that's not too, 12 divided by 8, that's okay. We'll just write it like that. So the n is 1.5, and everyone has done it like that. So 1 to 1, 1.5. And what that's really telling me is that the second number in that ratio is 1.5 times the size of the first number. So you're kind of scaling between one number and the next. So the 12 is 1.5 times the first number. So you can see that sometimes having the ratio in this form is useful. So here's another example. A jug of juice is made by mixing 200 milliliters of squash with 1 litre of water. Now, for those of you that don't live in the UK, squash is just like concentrate, you know, that you fruit concentrate and you add water to it to make up a drink. How much water is needed for every milliliter of squash? Okay, have a little think about it. So we're given two amounts. Now this time we've got units to deal with. 200 milliliters and 1 litre. Who can tell me how many milliliters there are in 1 litre? So I would work in, oh, Helen, you go, you can come back later on. Sidra, thank you. So 1 litre is 1,000 milliliters. I know we've not done conversion of units yet, but hopefully it's something that you've come across before. So that's 1,000 milliliters. So that's our proportion there. So we've got 200 milliliters to 1 litre, which is equivalent to 200 to 1,000. Get rid of the units once they're the same. 200 to 1,000. Now, both of those can be divided by 200. 200 divided by 200 is 1, and 1,000 divided by 200 is 5. So our ratio of squash to water is 1 to 5. So for every 1 part of squash, I've got 5 parts water. So, and that's the answer. So 5 milliliters of water is needed for every milliliter of squash. So tell me, if you're there live and you want to think about this, if I had a glass of squash, what fraction, or I shouldn't say squash, but if I had a made up glass of this drink, what fraction would be squash? If there was 1 milliliter of squash for every 5 milliliters of water, what fraction would be squash? Have a little think about it and type it in the box. So some people think 1/5 and some people think 1/6. So let's have a little think about this. But here's my glass, like that. That's a really rubbish glass, I know. So I've got 1 part squash. This is squash here. I'm just going to shade it in. And 5 parts water. So there's 1 part squash. Do diagrams because it does help you work things out. 1, 2. I'm going to fit in 1, 2, 3, 4, 5. I'm just going to add 2 more to stop. It's a very long glass like that. Okay, so we've got 1, 2, 3, 4, 5 parts water and 1 part squash. So altogether, there are 1, 2, 3, 4, 5, 6 parts. So the amount that is squash is 1/6, and the amount that is water is 5/6. So when we're converting between ratios and fractions, you need to be careful to add the 2 parts together, and that's what it's out of, because that's the total. So 1 to 5 means that 1/6 is squash and 5/6 is water. Does that make sense? Okay, and most of you have said 1/6, but writing 1/5 is a common mistake, so you need to be very careful. And if you're not sure, draw a quick diagram, and that should sort it out. So let's have a look at some uses and contexts where we might have ratios. So if we know the ratio of one quantity to another, and I know how big one of them is, you can use ratio to find the size of the other. So this is like finding the missing number, and we're just going to use the idea that we multiply both numbers by the same thing, or divide both numbers by the same thing to keep the ratio the same. So here's a typical kind of problem that I might be asked. So a recipe uses flour and sugar in the ratio 3 to 2. So for every 3 parts flour, there'll be 2 parts sugar. If I have 180 grams of flour, how much sugar will I need? So what do we do here? So what we need to do is find out how much we've multiplied the 3 by to get 180. In other words, 180 divided by 3, and that will give us that number. And then we need to multiply the 2 by the same amount. So it's just like scaling to make an equivalent ratio. So what I would do is I would start by writing the 3 to 2 at the top. And then underneath we've got 80 to the number that I'm trying to find. And then what I need to ask myself, well, what have I multiplied 3 by to get 180? In other words, what's 180 divided by 3? Well, I know that 18 divided by 3, or I should know if I know my 3 times table, 18 divided by 3 is 6. So 180 divided by 3 must be 60. So that means I must multiply 3 by 60 to get 180, which means that I need to multiply 2 by the same amount just to keep the ratio the same. So we multiply both sides by 60. If I multiply 2 by 60, I get 120. So if I've got 180 grams of flour, I'm going to need 120 grams of sugar. Is that okay? I think most people got that. Abdallah, I'm not sure where 108 to 72 comes from. You may have misunderstood the context of the question, but hopefully what you see on the slide there makes sense. So you need 120 grams of sugar. Here's another question. So now we've got the ratio of cows to sheep on a farm is 5 to 8. So what that means is that for every 5 cows, there are 8 sheep. If there are 72 sheep on the farm, how many cows are there? So it's a very similar problem to the one that we just looked at, except there's no units involved, so maybe that makes it a little bit easier, I don't know. But be very careful, because the number that we're given here is the sheep, which is the second number there. So I think that's probably the hardest thing about this, is to make sure that you're looking at the right numbers. So start by writing down 5 to 8, and underneath put the 72 in the right place. So this is cows, so I'll just put a C for cows, and this is sheep, so I'll put an S for sheep. So 72 sheep means I've got to keep it underneath the 8. And then in exactly the same way as we did before, I need to say, well, what do I need to multiply 8 by to get 72? Or in other words, what's 72 divided by 8? Hopefully you know your 8 times table, and you realise that, I'm trying to work it out myself here now, that's 9 times, isn't it? And then you need to multiply the 5 by the same thing. As I mentioned before, as long as I live, I will never know my times tables off by heart. Some people just don't. I can work them out, and I know when I'm right, but it's just something I've never been able to memorise. I know it's a strange trait in a mathematician that I just can't keep numbers in my head, but I do my best. So we're going to multiply both of these numbers by 9, and I'm seeing some answers come up on the screen, so good, that's right. So we multiply both numbers by 9, so then we have to multiply the 5 by 9, and 5 times 9 is 45. So 45, that's right, Ahmed. 45 cows. Rumnik, you got it first. Lisa, you got it ages ago. And Sidra, you were way ahead. 45, good. Multiply the right-hand side by the same number. So the number of cows is 45. Okay, so that's easy enough. Some of these ratio problems can get really complicated later on, but get the hang of the basics first, and then we'll do some more complicated ones another time. Now, I've mentioned this briefly, but it does come up. You can use ratios to write a quantity as a fraction of a total amount. So we can convert between ratios and fractions. So supposing we're told that the ratio of bananas to apples in the supermarket is 4 to 5. So that means for every 4 bananas, I've got 5 apples. And we're asked what fraction of the fruit are apples. So what you need to ask yourself is how many fruits are there altogether, regardless of whether the bananas are apples. So we just want the total. Remember, when you write a fraction, the number on the bottom would be the total amount. So what I need to do is I've got 4 parts to 5 parts, is I need to add those two numbers together. 4 plus 5 is 9. Thank you, Sidra, Ahmed, Violet, Rob, all getting it right. And 5. So 5 apples out of 9 fruits altogether. So the fraction I want, actually, don't make the mistake of writing 5 out of 4 or 4 out of 9. You need to add the two numbers together to get the total amount. So there's 9 parts altogether. And 5 of the parts are apples. So 5/9 of the fruit are apples. Happy with that? Okay. This can come up in other contexts. So sometimes in more complex problems, we need to then take that information to work out something else. Now here's one that involves dividing something into a given ratio. And we kind of use the idea of fractions here. There's different ways of thinking of it. So supposing we want to divide this sum of money, £400, into the ratio 3 to 7. One way to do it might be to say, well, there are 10 parts altogether, because 3 plus 7 is 10. So the first part is 3/10, and the second part is 7/10, and then I could just say 3/10 of 400 in the first part, and 7/10 of 400 in the second part. So that's one way that you could do it. So what we normally do in the first step is we want to know how many parts there are altogether. So you need to add the two parts of the ratio together. So if it's 3 to 7, we add 3 and 7, and we get 10 parts altogether. The next step will be to divide 400 into 10 equal parts so that I know the value of each part. 400 divided by 10 should be quite straightforward. 400 divided by 10. I've purposely chosen quite easy numbers just so that we can focus on the method rather than having to get caught up in arithmetic. So each part is 40. So 400 divided by 10, so each part is worth 40. And we've got 3 parts to 7 parts. So to find the value of the first part, we need to say 3 times 40, which I know I'm seeing lots of correct answers, Rob and Sidra and Abdallah, Ryan and Rayan. Am I saying that correctly? And Violet, I think you've got it already. So 3 times 40 is 120, and then 40 times 7, 4 times 7 is 28, so 280. And then in the last step, make sure that those two numbers add up to 400. So just to make sure that you've done it right, you should add those two numbers up. Make sure that it comes to 400, so that the shares are 120 and 280. And sometimes they'll say Abigail and Ben, these are the A-B letters, share an amount of money in this ratio, and that's how you would write that out. So make sure that they do add up back to 400. Now here's an example where we've got a ratio with three different numbers in it, and that's fine. You can do that with ratio. There's no limit. It's not like a fraction where we just have one number above another. You can have several. So let's have a think about how this works when we've got three different numbers in the ratio. So in a group of 120 people, the ratio of blue eyes to brown eyes to green eyes is 2 to 3 to 1. So this number 2 is, I'll call it BL, won't I, for blue. So blue eyes is 2, brown eyes is 3, and green eyes is 1. And I'm told that there are 120 people. So the first thing to do, it works exactly the same as the previous example, is to work out how many parts there are all together. So I've got 2 parts to 3 parts to 1 part. 2 plus 3 plus 1 is 6. So each part is worth 6. Each part is worth 6. Then I need to divide 120 by 6 to find out how many people are in each part. Once I know how many people are in each part, then I can multiply up to give me the relative, the number of each colour eyes in the group. So we've got brown eye 60. Good, that's the easy one to work out, I think. Oh no, well, I mean, actually, I think the green one is probably the easiest one to work out. So we've got 20, and then the others are just multiples of that. So once I know that the green represents 20, I can multiply up. But let's look at the steps in the calculation. So the first step is add up the 2, 3, and 1 to get the number of parts. Next step, divide 120 by 6. Again, I'm choosing easy numbers just so that we don't get distracted by the arithmetic. 12 divided by 6 is 2. So 120 divided by 6 is 20. So 1 part is worth 20. So we've got this number here already. 1 part is worth 20. This 2 here, 2 times 20 is 40. And then for the middle one, 3 times 20 is 60. So we just work each one out. Oh, well, the question was brown eyes. I should have read the question properly, because the question just said how many people in the group have brown eyes. That was me trying to work out all of them. So if you're right for not reading the question properly, so yeah, everyone does it. So 60 people in the group have brown eyes, which I know, Lisa, you said the correct answer 60, and so did Sidra. Everyone else was doing what I did, which was just to work it out for all of them, which is useful as well. I'll pretend that I read the question properly and was just testing you. Now, some people are more visual. Some people find it quite hard to, divide things into equal parts and all of that. So I'm just going to show you another method here, which is described in your textbook if you want to look at more examples. I mean, you'll see, I'm going to give you a link to some videos, and some people prefer to draw, just like I did with the glass and dividing things into lines. If it helps you to draw diagrams to help you work these out, then please do that, because that's part of your method. If that's the way that you visualize things, then it's a good idea to do it that way, especially with the slightly more complicated questions. So when I say the box method, don't confuse it with the grid method. It just means drawing boxes for each part. So here's a little slightly more complicated example. I think I even took this from the textbook. So a group of 3 office workers form a lottery syndicate. Together they buy 8 lottery tickets every week. Simon pays £1 a week, Oliver pays £3, and Lucy pays £4. And they win £32,000. Yay! Should they get an equal share of the winnings? If not, how should they share their winnings? What's the fairest way? So I think what we're suggesting here is that the fairest way would be to divide it as a proportion of how much they pay. So it's not fair if Lucy pays in 4 times as much as Simon, that she should get the same amount. We're not just going to divide it by 3. We're going to say, okay, Lucy will get 4 times more than Simon, and Oliver will get three times more than Simon. So one way of thinking of dividing this up, there's different ways. For example, you could just say 4 plus 3 plus 1 is 8. So Simon should get 1/8. Oliver should get 3/8, and Lucy should get 4/8. But some people aren't very good with fractions, and they'd rather do a diagram. So you could also do it like this. So I'm going to draw a box for each of the shares that each of the people should get. So Simon has 1 box, Oliver has 3 boxes, and Lucy has 4 boxes. And I can see lots of correct answers coming up there on the screen, but let's just have a look at this visual way of representing it. And every box has to have the same amount in it. And there are 8 boxes altogether, and we have to share £32,000. So if we have to share £32,000 into each of these boxes, and there's 8 boxes altogether. We need to work out 32 divided by 8. 32 divided by 8 is 4. That's that one that I had to stay in at break that time because my teacher asked me what's 4 times 8, and I got it wrong. So this times table always causes me anxiety attacks. Yes, 8 times 4, so 4,000. So each of these squares is worth 4,000. So then what we do is we put 4,000 in each of those squares, and then, so yeah, 4,000 in each square, and then we can work it out. So Simon will get 4,000. Oliver will get 3 lots of 4,000. 3 times 4, 12,000. I just look in the chat box. And Lucy will get 4 times 4,000, so 16,000. So we just put it in there. So Oliver 4,000, 12,000, and 16,000. So we just imagine 4,000 in each box. 4, where 4 stands for 4,000. I suppose I could say 4K. So we've put 4,000 in each of these boxes. Does that help you visualize a little bit more how these are broken up? And this is a slightly harder question, I suppose, because we're dividing between 3 different people. So if you get fractions, you'll get ratios, just a slightly different way of comparing 2 different amounts. I'm gonna stop there. I know I'm only just halfway through, but I'm just gonna give you a link to some ratio videos. So on Hegarty Maths, there are some really good video questions here. So paste that in. Actually, I'm linking this to YouTube, so this will take you to a YouTube playlist. And what I'm going to do, because I want to give you your money's worth. I've really covered everything, but what I'm going to do is I'm going to share my Hegarty Maths in a moment, and we'll go through some practice questions using Hegarty Maths to give you a view of what that looks like. You don't have to buy it, but it's really good. So I'll do that to fill in the space for the rest of the lesson. So try that link, and I know I've only done a couple of examples for each thing. So, and on here you've got comparing quantities using ratios, simplifying ratios, writing ratios as fractions of proportions. Now, the screen is going to blink in a second because I'm just going to start sharing my desktop. So if you just give me a moment and I'll set that up. Okay, now because we've got a few minutes left, what I'm going to do is I'm going to load up the demo version of MathBuster. I just realised that it's got a section on ratio on there. So this MathBuster is really good. You don't have to buy it, but it's a good option for practicing lots of questions, and I'll show you the demo now. So this link that's here in the chat box, I'm sorry, Ahmed, fairly easy. If you encounter a different question, it puts you off. I think the key with difficult questions is really just to break them down into simple steps. So look at the information that you're given in the question. Even if you can only work out part of it, make the first few steps, and even if you don't get to the final solution, you'll get some marks for making a start. So I'm going to open up this demo version. So if you use that link, people who are watching live or watching the WebEx version, if you're watching the YouTube version, it'll be underneath. Open that. I'm going to share my desktop to show you what it looks like, but what you'll see is a demo version. So that's the demo version there. It's the higher tier, so some of the questions are more difficult. And click on Browse Revision Topics. I'll share my desktop with you now, so that the screen will just flash for a moment. Share my desktop. Okay, that's the link to MathBuster there. I'll just put that in there. So this is the demo version. This is demo there. So you can try some of these time tests, leveled practice questions. This starts at level 4. I suppose that's roughly equal to grade 4. But the section that I really want to look at today, and this is all free on the internet, so you only have to pay if you want the full product. But it's only $12.99, so a lot of my students that have this find it really helpful. So go into Browse Revision Topics, and in the demonstration topics, there is a section on ratio and proportion. We've got ratio tricky problems. So let's click on that. And what you get here is some revision notes. So if you're watching the recording and you want to pause and have a look at that, this is just a copy of what you get in the revision guides, and this is just what we've already been through for dividing a number in a given ratio. Add up the parts, divide to find one part, and then multiply to find the amounts. And then we've got section 2, which is changing ratios. Now, some of these are a little bit more difficult, so the one underneath involves some algebra, but this is from the higher tier book, so you should be able to do the first part of these. So let's have a look at a few questions. There's also videos in here, so if you're using the demo version, have a look at the videos. There's a video for dividing in a given ratio, and there's ratios and simultaneous equations, which is a much more advanced topic if you're doing higher tier. So you'll notice as well, when you look on the browser revision topic section, it tells you the target grade. So there are quite straightforward and easy ratios for people doing grade 4 to 5, and then if you are doing more advanced higher tier ratios, it will be more algebraic problems, and those will be more targeted towards grades 8 and 9. So let's have a look at some of the questions in here. They're different every time, so I can't predict, so we'll work on them together. People who are watching live can help me work them out. So what I would like you to do is, if you are watching live, could you take your mouse, drag it to the very top of the screen until the drop-down menu comes down, and then click on chat. So this is just for people watching live, just so that you can help me out, because you know how I panic when I can't work out times tables. And then you can tell me the answers and I can type them in. Oh, don't worry, I'll help you out as well. So once you've opened up the chat box, can you just type OK, just to let me know that you've done it. So scroll the mouse to the top of the screen. Lisa Henricks, OK, so you've got the chat box open. Violet, OK with smiley face, thank you. So you've all got the chat box open. Done, cool. OK, number one. Let's hope they're not too hard. So the first one, that's quite easy, I can do that, and with no calculator. Divide 36 in the ratio 5 to 1. I'm just going to scroll down here a little bit. What do you reckon? Divide 36 in the ratio 5 to 1. So the first thing we need to do is how many parts are there? So the 5 parts to 1 part. How many parts are there altogether? 5 plus 1 is 6. So there are 6 parts altogether. How much is each part worth? 36 divided by 6 is 6. So the first bit, 5, we need to do 5 times 6. So let me just type that in the box. Yeah, Ryan Schultz said 30 to 6. All right, let's try that. So 5 times 6 is 30, and times 1. If you run this demo and you do question 1, you'll get a different question 1 because it changes every single time you do it. So you always get a different question. So, and then 1 times 6 is 6. So 30 and 6. Let's mark it. Nice one, we got it right. And the great thing about this as well, and I don't work for CGP, but I just want you to know this if you're using the demo version. If you're not sure how to work it out, you can click on show a worked example there, and it will show you how to work it out. So for example, divide 42 in the ratio 6 to 1. Add the 2 parts together, 6 plus 1 is 7. So 1 part is worth 6, and then you work out 6 times 6 and 1 times 6 to get the 2 numbers. And if you wanted to do that question again, you could just press that and you would generate a new example. Divide 21 in the ratio 1 to 2. 1 plus 2 is 3. So 21 divided by 3 is 7. So that would be 7. Good practice of your times tables, these. 7 and 14, mark. There we go. So you can really just practice these kind of questions again and again and again. So something like this where it just randomly generates questions like that. Sometimes the same question comes up again. So 45 in the ratio 1 to 8. But it's a really good way of practicing these kind of questions. So I would advise working through as many of these as you can. The later ones are much more difficult. Let's have a go at question 2. Just keep an eye on the time there. So we want to divide 5,000 meters in the ratio 7 to 3. It's very similar to the last question. 7 parts to 3 parts is 10 parts altogether. 5,000 divided by 10 is 500. 7 times 500. What's 7 times 500? 7 times 5, 35. Oh, I don't want to do this on the spot. Is it 3500? 35. I think it's just 350. Yeah, I think I'm getting myself mixed up. 500. Yeah, because it's thousands. Yes. 3500. And then 3 times 500. 3 times 5 is 15. Does everyone agree with that? Is it 300? It can't be 350 to 150 because that would just give me 500 and I want 5,000. So sorry, Gemma, if I was getting it mixed up myself, but I needed the extra O in there. So make sure that the 2 parts, when I add them together, give me the same as the number that's there. Right, I'm confident with that. Are we ready? Yeah, simplified it. I think I don't know what I was doing. Let's mark it and see if we're right. Nice job. And if you think, right, I need a bit more practice of that, then you can just press retry and try another one. Well, that looks hard. Oh, no, but it's not hard because 41 plus 9 is 50. 4,000 divided by 50. So 4,000 divided by 50. 400 divided by 5 is, I think, 800. That sounds hard. And then we put the zeros in the right places. I don't think I can do that in my head live online. I told you I'm really rubbish with numbers. Somebody tell me what it is. What's 9 times 50? Is it 9 times 50? I don't even know myself. I want to get my calculator out is what I want to do. I know I'm not supposed to because there's a thing there saying no calculator, but you know I'm a terrible cheat and I just want to make sure I'm getting the right answer. I just got a free trial version of my calculator. Whew. I'm happy now I've got a calculator in front of me. Bernice, if you're doing IGCSE, you'll be pleased to know that both papers are calculator papers, so you won't ever have to do anything like this in your head. So now I know how to work it out. I'm just going to do it on the calculator. Please forgive me for cheating. Normally my brain should be a calculator, but I just don't have the confidence. So we do 4,000 divided by 50. So 4,000 divided by 50. Please forgive me for cheating, is 80. Thank you. I think somebody did tell me that a minute ago. 80 times 9. I do know 80 times 9 is 720, isn't it? So 80 times 9 is 720. And then 41. Oh, no, I can't do that, can I? 41 times, was it 41 times 80? 3280. Who could do that in their head? Or maybe I could do 40 times and then 1 time. Anyway, wicked. And so is that jumper. They try to be funny on these CGP things. So anyway, you get the idea. I could do it easily if I had a calculator. Now this one lets me use a calculator, which is great. So how do we do it with a calculator? We've got 400 cows in the field. Ratio of black cows to white cows is 9 to 1. And we don't need a calculator with that. That's quite an easy one, isn't it? Because we just add the parts together. So 9 plus 1 is 10. 400 divided by 10 is 40. So we've got, sorry, black to white, so then we need to do 9 times 40. 9 times 4 is 36. So 360, is that right? Hope so. I don't want to get it wrong. Awesome. Is that a new haircut? This is trying to compliment me now, this machine. And you can also press click and show a worked example. Let's try one more. And then if you want to do these, you can work through them to your heart's content, and they're very good practice. If you don't feel like writing, you just want to practice without writing anything down. So this looks a little bit more complicated. We've got some reading to do. Margot is 13 years old. Her sister Sarah is 4 years older. Okay, so she's 13. Her sister must be 17. They share out £3,000 in the ratio of their ages. How much does each girl get? And I'm happy that I can see that calculator button there, because that will help me. So Margot's 13, so her part is 13. Sarah's 4 years old, so that's 17, so add on 17. So each part, so there's 30 parts altogether. 300 divided by 30 will give me the value of each part. I don't need to do it on my calculator, but I've started now. 300 divided by 30 is 10. So each part is worth 10. So they share that in the ratio of their ages. So Margot will get 13 times 10, which is 130. And Sarah, who's 17, will get 17 times 10, 170. And then as a final check, make sure that 130 and 170 adds up to 300, and it does. So I know that I'm right. So let's mark that. Awesome, got it right. Should we do one more? Do you want to do one more, or are you happy to try these yourself? I think the questions get more difficult as you go through. So if I skip to question 9, we've got an example of a ratio that's got 3 parts in it, 4 to 7 to 8. So a family of 3 share out the time spent on ironing each year in the ratio 4 to 7 to 8. Who would actually do that? That would be very sad. The ironing takes a total of 380 hours per year. What's the least amount of time a family member spends on ironing each year? So I think that would be that 4-bit thing here. So this is allowing you to use a calculator. So if you want to work this out, what you would do is just the same as the ratios that have 2 parts in them, add the 3 numbers together. So I'll do this one. 4. If you try this yourself later on using that link I gave you, it will be different questions. So that will give you an idea of how to do it. So 4 plus 7 plus 8 means the parts add up to 19. Divide 380 by 19. Now I realise that all of these problems are involving dividing a number into a given ratio. If you want more ratio type questions, you would have to buy the full product, which is $12.99, and then you'd be able to access all of the sections, not just the demo questions. So that's 20. So the person who is the 4 parts, I would need to do 4 times 20 because each part is worth 20. So 120, so 20 times 4 is 80. So I think it's 80. Sidra and Lisa agree with me. And Gemma, you've even gone to trouble of working out everybody's time allocation in this problem. But we just need to want to know the one who has the least. I think it's 80. Let's mark. Excellent. Well done. Okay, I'm going to stop there. If you want to try, some of these harder ones may go beyond what I've covered in this lesson. I'm not sure. So the questions get progressively more difficult as you go through. Penguins, that should be all right. I don't know how hard the harder questions get. This last one has got some algebra in it. But if you're aiming for higher tier, give it a try. Okay, I'm going to close this down now and stop sharing my screen. So stop sharing. Flash back to my slides. So yes, so do go on and try the demo version. If you buy the full one, there's lots of different questions for each section, as well as revision videos, and also worked examples for every single question. So if there's a question you can answer as you're going through the practice questions, you just press worked example, and it will show you an example of that question. So you get an awful lot for £12.99 if you do. If you're someone that is quite happy sitting in front of a computer screen and doing interactive questions rather than working from a textbook. If you want some more practice questions, so I'm just going to go back a bit. As I said, have a look at chapter 19 in the foundation tier book if you're using that. If you're using the higher tier book, it's chapter 20. I gave you links at the beginning. If you're using this easier book, there's ratio problems on pages 49 to 51. So if you find the textbook hard and there's too much text and too much to take in, the questions can be quite challenging even in the foundation tier book. Just get this foundation tier workbook, or even the Key Stage 3 book, which is very similar and covers most things up to about a grade 4. So you could buy either of those, and you can get them used on Amazon for a couple of pounds. I'm glad that ratio is starting to make sense to you. I mean, with all of these things, it might seem a little bit strange at first, but as you get more confident, things will start to fit into place. And what you'll find is, supposing you were just really not getting fractions, you're finding fractions really hard, and you just gave up on them, and you decided to do ratio instead. Everything in maths is interlinked, and the more maths you do, and the more confident you become, the easier you'll find other topics. So even though ratio doesn't cover fractions in the same way, getting an idea of ratio will help you with work on fractions and work with proportion, and all of these topics are all interlinked with each other. So if there's ever a topic that you're really struggling with, just leave it and go back to it later on once you've done some more maths, because it doesn't matter if it's a completely different topic. As you go through, things will get easier. Bernice, sorry, no, if you're doing IGCSE maths, you have a calculator for both papers. There's no non-calculator work. So IGCSE maths doesn't have anything that you have to do without a calculator, which would be good for me because I hate having to do mental maths and work things out in my head. So it is a little bit different. But if you're doing IGCSE, make sure that you send me an email so that I can explain the differences to you, because it's not the same as EdXL 9 to 1. The foundation book, does it cover everything you need to know? If you're doing the foundation exam, sorry, do you mean does it cover everything you need to know for IGCSE? I think it might. I'm not sure. I would have to double check the exact specification details, because the IGCSE is still graded up to a grade C on foundation tier rather than a grade 5, which is worth more than a grade C, so it might be a bit different. Although the IGCSE is moving to the new 9 to 1 scale soon. There's also some very good practice questions on the Maths Genie website. Let me just give you that link. So if you go to Maths Genie and you scroll down to the grade 3 section, a grade 3 is roughly like a grade D kind of level on the old scale. There's 3 sections there: writing and simplifying ratios, writing one ratio as a fraction of another. Now these two just have a revision video if you want to watch some more video examples. But this middle one, you've got some exam questions and solutions, so click on those and you've got some more practice there. So you don't have to use the textbook at all. If you would rather just work through these instead, that's fine. But what I would say is, for every lesson that you watch, please make sure that you spend at least 2, or if you've got time, 3 hours doing practice questions for each one, just to make sure that you really know how to answer questions. It's not enough to just make notes and learn the notes. It's not like other subjects where you learn things off by heart. You learn maths by doing maths. So it's important that you do as many practice questions as you can. Now, we've finished all the number work for Unit 1. I'll be going back to more number work and building on these topics later on when I go back to Unit 2. Next lesson, I'm going to introduce algebra, everyone's favourite topic and the language of mathematics. Can't do maths without algebra, so it's very important that you have a good understanding of that. There's no avoiding it, even at foundation tier. Of course, higher tier will have a lot more algebra in it, but you still need to know quite a lot of algebra for the foundation tier paper. So next lesson I'll give you a quick introduction to algebra, because you'll be using algebra a lot in maths. Very important, you can't avoid it, as I have just said. So please join me then. Yes, Benny, email me. Has anyone got any questions before I let you go? Hopefully all of that was okay, and things are starting to make sense and fall into place for you. If you've enjoyed that lesson, please, I know I always say this, but I really like getting reviews. It makes me feel that all the work I do is worthwhile. And honestly, these webinars are a really unique feature of the course. So it's important, they're a big selling point for us that you get all of these free online lessons. So if you've enjoyed the online lessons and you found them helpful, please take a few moments to leave me a review. Please say my name. If you don't say my name, then no one will know that it was my hard work that got the review, and that would be much appreciated. It only takes a minute, even if you say Melissa's lesson was great. If you thought it was rubbish, then I'm not going to stop you, but nice feedback would really make my day. And if you need to contact me or anyone here at ICS Learn, same contact details. You can contact your tutor for help with anything that you're working on in the textbook or in any of your course materials. If you want to contact me, you can. My phone number, my email address, or chat to me on the forums. I kind of go in and out all of these forums. Other courses with ICS Learn, that there won't be anyone looking at those forums, but because I work here online as a teacher, I'm allowed to go in and answer things on the forums. And if you need to ask a question from student services, anything that's not maths related, don't ask them about maths, because they'll have a panic attack. Nicola, you're getting over your fear of fractions. If fractions are making you feel anxious, please just leave them for now and go on to something else. But then, I mean, algebra might make you even more anxious. I don't know. Some people do quite like algebra, and hopefully, I can help you kind of see the algebra and figure it out. And you know, we'll get there. We'll get there. I'm here to help you. Okay. Thank you very much for coming along. If you're watching live, thank you for watching the recording. And of course, guys watching the recording, you may also go to Trustpilot and leave me a review. It's not just the live people. So I look forward to that. And I will see you. Gemma, keep trying. If you're struggling with decimals, the message is the same. Do what you can. Do as many practice questions as you can, and then just go back to it later on. So it's better that you spend just a few hours on every topic, go through everything in the course once through, and then at the end, leave yourself a month or two to just go back over everything again, and then you'll be able to see which things you're good at, which things you're not so good at. In this year's foundation tier exam for 9-1, the pass mark was 51%. So even if you hadn't have answered half the questions on the exam paper, you would have still have achieved a grade 4. So that's just to say that the papers are getting so much more difficult, that all of the grade boundaries are moving. Now, I can't guarantee that the next grade boundary will be 50% for a grade 4, but it's just to say you're not aiming for perfection. Even if you're doing foundation tier, if there's questions that you can't answer, it's not the end of the world. Just do the best you can. All right, thank you for watching, and I'll see you next lesson, hopefully. Bye-bye.